just normal neural network. So, okay, let's say in this ASML, okay, let me draw the model first. So we have symbol 1. This is our input layer, and this is our and this is our hidden layer, and then there's only one output layer. Okay, and then we have this is the fully connected. Okay, nodes are connected like this. Okay, and then we have the input here and here. Okay, like this. And then, okay, so that's why this is our output. Okay, let's say this is white cap, or let's say this is maybe A to be the, okay, so this is A, and then, okay, okay, A is the output of here, and then also we have the target. Okay, so this is our target Y. Okay, and then we have, okay, this is H1, this is H2. Okay, and then actually let's assume that we have H0 is equal to 1. Okay, so that is mean we have bias, okay, things, but I will not show you in here. Okay, and then this is 1. Okay, so let me write all output in here. Okay, so in this output, so this is input. This is the input. Okay, and this is hidden layer. Okay, and this is the output layer like this. Okay, and then let me define like this. So this is 1. Okay, and this is 1, 1. This is 2. Okay, this is 1. This is 2, like this. Okay, and then we have weight in here. This is 1, 1. Okay, it's because this weight is connected between this node 1 in the next layer with the node 1 in the previous layer. Okay, and this weight W is 2, 1. Okay, and this weight is W 1, 2, and this is W 2, 2. Okay. And then we have, this is layer one. This is layer one. This is layer one. This is layer one. Like this, we have it is. And then, so this output, okay, this is just the input node. Okay, so this output is just H1 and this is H2. Like this we have. Okay, and then this is layer one and this is layer two. Okay, this is actually the output, and then this layer zero is mean our input. Okay, so in this case, from here we have the output. Okay, let's say A1. This is, let's say, 2. Okay, so it's output or input is 1, select 2, 2. Okay, so this is being the input for the layer 2. Okay, and also here we have the weight 1, 1, but this is as a 2, layer 2, and weight 1, 2 as a layer 2, like this. Okay, so for this A, okay, to be used as the same format as here, let's say this is 1. So this is mean H1, sorry, A1 as a layer 3, like this. Okay, and please always keep in mind this, all for this A, okay, A for any I, okay, I is referred to the node, any layer, okay, is equal to uh, a division function with the parameter of C I like this. Okay, and this one is calculated by weight multiply each input for each layer, like this. Okay, so let me define like that. And then in this case, okay, in this case, let me define this is x0. Okay, this is 0. Okay, and then also in here, that is that weight. Okay, this is mean W 101 like this. Okay, in here also we have, okay, 1 in here. This is just a value 1. Okay, and then we have another weight. Okay, that is mean W102 like this. Okay, or we can say, okay, to be the made it easy for our life. So this one is like the bias 2. Okay, and this is the bias for other. Okay, like this. Okay, but in this case we have only 1. But here we have bias for this one, and also we have 2, 0 like this. Okay, so I think, okay, if we use many, let's delete this one. Okay, so please keep in mind that this one is whatever start with end with 0 in here. So start from the 0 node is just being the bias. Okay, we can consider like this. Okay, and then in here, let's define Okay, let's define. Okay, let's define like this. For the W10, okay, for the layer 1 will be equal to 0.8, okay, and then W11, okay, layer 1 will be equal to 0.5, okay, and then after the W12, layer 1, okay, this is layer 1, is equal to 0.4. Let's assume that, okay, and for this node, okay, for this node 2, this is being W20 layer 1. Let's assume that is equal to 0.1, okay, and W21 layer 1, let's assume that this is equal to 0.9, okay, and then W22 layer 1, let's assume that this is equal to 1, okay, and this is for the layer 1. And then for the layer 2, okay, 10 layer 2, okay, let's say it's minus 0.3, okay, and then weight W11, okay, layer 2, this is being this one, is equal to minus 1.2, and then W12, okay, this one, layer 2, is equal to, let's say, 1.1, like this. And then, in our case, to be the symbol, let's assume that H1 is equal to 1. H2 is also equal to 1, okay? And then, for this case, our target, okay, y is, let's say, 0, okay? Our target is y is 0, okay? And then, let's calculate, okay? Let's calculate or let's update the weight based on this data set, okay? In this data set, H1 is 1, H2 is 2, and then based on that one, okay, it is belong to the category y is equal to 0, okay, or y or t is equal to 0, okay. So in this case, okay, in every training process, okay, the first thing what we have to do is we have to calculate the forward calculation, okay, forward propagation to find this A1, 3, or 1 cap, okay. So to calculate this one, okay, let's start with the layer 1. Okay, because layer 0, there's no calculation because it's direct transfer, okay, this one. So in the layer 1, okay, for each node, okay, before we calculate the A1, A2, we have to calculate the C1, C2. Okay, so for the C1 is being, okay, let me use a different color. Okay, so C1, 1, this is being the C1 in this node, okay, it will be equal to, okay, W10, 1, okay, multiplied with 1, okay, plus W121 multiplied with H1 plus W121 layer 1 multiplied with H2. So it will be equal to 0.8 multiplied with 1 plus 0.5 multiplied with H1 is 1 and 0.4. Okay, because this is this W121 multiplied with H2. Okay, H2 is also 1. Okay, and it will be equal to almost. Any mistake? Sorry, this should be the, in my example, this should be the minus. Okay, this is minus. Okay, this is minus. Yes. So that's why this is a minus. Okay. Okay, this is a minus. If you calculate this one, okay, if you calculate this one, you will get 0.1. Okay, because this is 0.9, this is minus 0.1. Similarly, we have to calculate the C21. Okay, C21 is mean before we calculate the A2, AR2, okay, we have to calculate that C2, AR1. Okay, so similarly, this one is 2, 0, 1 multiplied with 1 plus 2, 1, 1 multiplied with H1 plus 2, 2, 1 multiplied with H2, like this. Okay, so this one, if we substitute it, so W20 is 0.1 multiplied with 1 plus W21 is here, 0.9 multiplied with 1 plus W221 is 1 multiplied with 1. Okay, this will be equal to how much? This will be equal to 2. Okay, so please keep in mind that this is multiplication. Okay, and then after we got this one, I forgot to mention about that. Our addition function is just a sigmoid function. 1 plus E C. Okay. So that's why if we calculate A11, okay, we have to substitute that C11 in this wave function, okay, or logistic function is will be equal to 0.525. Okay, you can use a calculator to calculate this one. And then for this, okay, for A21, okay, A21 is being the output from here. We have to calculate, okay, separate functions, okay, 2, 1. Okay, so you have to substitute this 2 in here. Okay, if you substitute that 2 in here, you will get the 0.808 like this. Okay, so this is mean the output of, okay, output of this one and this one. Okay, this one is mean 0.125 and this one is mean 0.808. Okay, so in this case, this A1 and A2 will be appear as a input to this layer 2. Okay, so that's why I write on as a 2 in here. Okay, so this is actually should write down as a 2. Okay. Actually, this is the output of layer 1, but the input for the layer 2, like this. Okay. So if we bring this one to the okay. So let me copy this one. Okay. So currently we have this one, and then we need to calculate. We need to calculate this A13. Okay. Actually, that A13 is being A1 doing here. That will control with 3. Okay. A13. Okay. Is this mean we have to use the same submit functions? Okay. And then we have to calculate this Z. Okay. 1. Let's say this one as a 3. Okay. Like this. Okay. So that's why we have to calculate that E13. Okay. So it's Z13. So Z13 will be W11. Let's start from the W10. 10 layer 2. Okay. Layer 2 with multiply with 1. This is actually bias. Okay. The same as this one plus A1 W12. Start from the 1. Okay. W11 2 multiply with A12. Okay. Plus W1 2 2 multiply with A2 2. Okay. So if we substitute this one accordingly, okay, and in the previous slides, okay, let me copy from the previous one. Okay. So this is minus 0.3 multiplied with 1 plus minus 1.2 multiplied with 0.525 plus 21. Okay. 21 is 1.1 multiplied with 0.808. Okay. I made the mistake in here. This is not 1 2. This is 2 1. Huh? No, 1 2. Yes, of course. This is 2. Yes, 1 2. This is 1, 2. Yes. Okay. This will be equal to almost. This will be equal to 0.0388. Okay. And then from here, we can calculate A13. Okay. This will be equal to, maybe this one, 2, 2. Okay. So it's easier for us. 2, 2. Yes. Okay. This will be equal to the same functions. Okay. Logistic functions. Okay. 0.0388. Okay. And then it will be equal to 0.5097. Okay. So now we got the estimated output. Okay. And then we know that this is equal to 0. So we can calculate the error. Okay. This error E. Okay. Is this mean that error is mean A minus Y? Oh, sorry. Let's calculate this. Y minus A. Okay. It will be equal to Y is 0 minus, okay, 0.5097. It will be equal to minus 0.5097. Okay. And then based on that one, okay, we can calculate the sigma. Okay, let me use a different color in here. Okay. So we already got the error in here. Okay. But actually what we want to, this is not the error. This is the difference between, okay, these two. Okay. But what we have to do is we have to calculate the error. Okay. That is mean sigma 1, 3. Based on this sigma 1, 3, okay, we have to calculate the sigma 1, 2 and sigma 2, 2. Okay, like this. So that's why first we have to calculate that sigma 1, 3. Okay, it will be equal to, okay, according to the derivative functions, okay, it will be equal to A 1 minus A, okay, because this is the error, okay, this is the error difference. And then if we move error to here, okay, we have the division function here, this G, okay, this one divided by this one is equal to multiply 1 minus G set, like this. Okay, so actually this is a A, okay, so that is why we got this one, A 1 minus A, okay, multiply with our E, okay. So A 1 minus A, actually let me write down that A with this value, okay. This A is mean not just a normal A, this is mean 1, 3, okay. So that is mean 1, 3, this is mean 1, 3, okay. So that A13 is this mean here, okay, this value 0.5097, 1 minus 0.597, okay, multiply with E is this mean minus 0.5097, like this. This will be equal to, okay, almost, let me write down here, minus 0.127. Okay, so this is being error. Okay, this has been the changes of the error. okay, or just an error, and then this error, okay, need to be transferred back to here and here, okay. So to transfer back to here and here, what we have to do is we have to multiply this weight with this error, this weight with this error, okay. If we multiply like this, we will get this error and this error, okay. So that is mean, okay, so this we finish for the layer 2, okay. We go back to the next layer, okay. That is mean we have to calculate the sigma 1, 2, and sigma 1, sorry, 2, 2, like this, okay. So for that case, what we have to do is we have to multiply the weight 1, 1, okay, because we have to multiply with weight with this 1, 3, okay. And then similarly in here, okay, similar to here, we have the activation fashion in here, okay, this A12, okay, and then we need to find the derivative of that one, okay, like I showed you in the last weeks, okay. So that is mean A12, okay, 1 minus A12, okay. So actually this is a derivative of, okay, we can say that this is a partial, okay, JW J A, okay, and this one is with the W1 like this, okay. Similarly, this one we have to multiply this 1, 2, okay, this is layer 2, and this is layer 2, 3, A, sorry, 2, 2, 1 minus, okay, 1 minus A, 1, 2, okay. If you substitute all the value, we have already calculated this A1, 2, and A2, sorry, this is 2 in the previous slides, okay. You can substitute it, and this A3, we already calculated in here. You can substitute it. This W11 and W22 is a given, okay. Based on that one, if we substitute all their value, this one you work at that 0.0381, okay. This one you work at that minus 0.0147, okay. And then after you got everything, okay, what we have to do next is, okay, you have to calculate the partial derivative, okay. This one is this 2 also, okay. This is just a partial derivative of JW, okay, with respect to partial derivative of A1, okay. This is A13, okay. This is A12, and this one is partial derivative with respect to A122. Sorry, A22, okay, like this. And then after that, we based on that one, okay, but actually we don't need to move in here anymore, okay. What we have to do is we have to find the partial derivative of J W divided by partial derivative of J W 1, 1, 1, 2, okay. So this is from the layer 1, and also we have to calculate the partial derivative of J with respect to W 1, 2. Sorry, let's start from the 1. Okay, this is 1, 2, 2, and W 1, 1, 2, like this. Okay, so if we can calculate this one, we can update the current weight. Okay, so to calculate this one, okay, what we have to do is we already find this one. Okay, so that is me. Let me write down in here. Okay, for example, for J W with respect to, let me to save the space, let me delete this one. 4 is equal to W11. Okay, this is mean to A1 3 need more space. Okay, A13 with respect to A, it's not A, C13 multiply. Okay, this is multiplication. C13 with respect to what is called A1, 2, okay, with respect to A partial C1, 2, and then multiply with respect to partial C1, 2 with W11 like this. Okay, but actually this one, okay, we use a different colors. Okay. We have already calculated. Okay, that is mean this one. Okay, and this one, sorry. This means this one. Okay, what less we have to calculate is wait. Yes, and then this one also we have calculated. Okay. Sorry, let me draw like this. Okay, that is mean that one. Okay, that is mean that one. Okay, and this one is mean. Okay, this one is mean. Yes, this one. Okay, this one is mean this one. Okay, what we need to calculate is this one. Okay, actually that one is C is WA's. Okay, with W, so it's just mean just an ace. Okay, so that is mean we just need to multiply with the input. Okay, to each of these ones. Okay, and then we will get this one, and then we just need to update this. Okay, so I will show you that one. So before continue, let me write down all the error we have calculated. Okay, so okay, so for this the first error, this 1, 3, okay, is equal to almost minus 0.1274. Okay, and then this one 0.0381. Okay, this 2 is minus 0.0147. Okay, so currently we calculate the error appear in here and here. Sorry, error appear in here. Okay, and here. And then what we have to do is based on that error. Okay, based on that error, we have to update them. based on this error, we have to update this weight and this weight like this. Okay, so how can we update? So let's start do that. Okay, that update is mean, let's say the data W. So this is our formula to update. Therefore, data W. Okay, actually this one is partial derivative of this one with respect to that W. Okay, can be calculated easily. Okay, so this is one is for the W112. Okay, this is mean for this weight. Okay, for this weight is can be calculated multiplied alpha. Okay, don't put alpha in here. Okay, alpha in here, and then partial derivative of J with respect to W11. Okay, so as I write down in here, okay, we have calculated everything except the last ones. Okay, this is mean alpha multiplied with sigma 1, 3, okay, multiplied with, oh, sorry, this is a 2, 2, okay, I made a mistake, 2, 2 is here, okay, that is mean, we already calculate this error, okay, multiplying with Kate, sorry, multiplying with the alpha, and then multiply with input A, 2, 2, oh, sorry, okay, A1, 2, okay, because let me write on that, repeat it. This is for the 2. Okay, so this 2 is this sigma 1, 3, and this one is A1, 3. Okay, so this will be equal to 0 0.1 multiplied with 0 0.525 multiplied with minus 0 0.1274. Okay, so I write down opposite D. Okay, this is A12, this is sigma 1, 3. Okay, like this. And similarly, we can calculate data. Okay, this one will be to update data 1, 2, 2. Okay, this will be equal to the same alpha. Okay, point alpha is, let's assume the 0 0.1. Okay, multiply. Let me write down the equation first. Multiply with A 2, 2. Okay, so this is 0 0.1 multiplied with minus 0 0.1274. Okay, multiplied with 822. Okay, 822 is almost 822. We have calculated 822. Yeah. Okay, 0 0.08. But 0.808 like this. So it will be equal to minus 0.0112 like this. Okay, so that's why for W112 for the current time, it can be updated with the W112, the previous time, minus, okay, that data W11. Okay, so is this mean the current weight? Okay, current weight is how much? Minus 1.2. Okay, minus 2.0112. Okay, here minus plus. Okay, so you can calculate this one. And similarly, W112, sorry, from the current next time t. Actually, this is for the next one, just t plus 1. This is current time. Okay, so t plus 1 can be calculated W122 current time plus minus theta W11. Okay, so this will be equal to current W12 is here, current W12 is here, 1.1. Okay, 1.1 minus W theta W11, theta W12. Okay, theta W12 is here. Wait, it mistake a lot. Sorry. This is minus. This calculation, we work at 0.0067. Okay, so that is mean 0.067. Okay, you can calculate this one, and then also this one 1.1. Actually, this is minus 0.011 like this. Okay, and also similarly, okay, similarly for the theta W111, okay, this can be calculated by alpha. Okay, alpha is the same. We will use the same rate, 2.1, multiplied with that sigma, multiplied with that sigma 1, 2, okay, multiplied with H1, okay, and then 0.1 multiplied with sigma 1, 2, we have already calculated it here, this one, 0.0381, okay, multiplied with H1 is just 1. So we will get this one, 0.0381. Okay. Similarly, this one we can calculate it also. The same alpha multiplied with 6.12 multiplied with H2. Okay, because this is H2 because of this is input 2. Okay, so that's why we have to write on H2. Okay, so that is mean 0.1 multiplied with 0.0381 multiplied with 1. So we work at the same weight here. Okay. And then you can update it that W111T is, sorry, T plus 1 into W111 current W plus minus theta W11. Okay. So this is almost 2.5, 0.5 minus 0.0381. Okay. Similarly, W121, okay, T plus 1 can be active from there 121 T minus delta W121. Okay, is will be equal to 2.4. Okay, 2.4 minus whatever you find here. Okay, we have to active. And also similarly, W, what is called that? 10 also. Okay, you can update it. T minus W 101. Okay, so for W101, I haven't found it yet. Data W101, we have to calculate the same training rate. Okay, multiply with that 1, 2. Okay, but this is a bias, so there's no input, just one. Okay, so if you calculate this one, you will get this one, and then you can substitute here. Okay, and similarly, you can calculate for the W1, sorry, W211 and W221, and for the bias W201 also, you can update this like this. Okay, so this is how to calculate the backward and forward calculations. Okay, so let's continue about the deep learning. Okay, actually the deep learning is part of the machine learning. Okay, it's a class of the machine learning algorithm, but it's used a multiple layer. Okay, actually in the origin of the neural network, okay, it have only the input layer, one hidden, or sometimes you can use the two hidden mostly, and the output layer. Okay, like this. But in the deep learning, okay, in the hidden layer, it's used more than two hidden layer. Okay, many layer, and then it's progressively extract the higher level of the feature from the raw input. Because normally in the normal or conventional machine learning on the neural network, okay, before we set the input, okay, or some we call as a feature, okay, we have to do the pre-processing. It just means we need to extract the feature first, okay, before we send it to the neural network or machine learning, and then after that we apply for the classification or prediction. But in the deep neural network or deep learning, it's not like that. We use a many layer, and then each layer, okay, will be extract this feature, okay, before we do the classification. But all are inside in the network. So that we call it a deep learning. Okay, so everything we put it in the one network. So the network layer is getting height. Okay, that we call it a neural network. Okay, so the what deep in the deep learning refer to the number of layer through with the data is a transform. For example, in the image processing, okay, in the image processing, okay, we have many layer, okay. At first, okay, what the image processing do is they just extract the feature. Okay, the feature is mean like if they want to classify maybe the bicycle, okay, it's like this, okay, they extract each feature or each structure, okay, separately, okay. That can be done by using the edge detecting. Okay, it's normally do as a lower layer, and then after that it will do the object. So we extract each stand, okay, and then after that we classify this is a wheel or this is a handle or something like that. okay, and then that is a object recognition. Finally, it can give you the answer 0 or 1. This is by scale like this, okay. So that is applied in the deep learning, okay. That's why normally in the deep learning, okay, it's used a heterogeneous, okay, various type of the layer, okay, different type of the layer, okay, different type of the different type of the layer can be combined together, okay, and each layer length transform input data to the slightly more abstract and composition representation, okay. So normally it's a process length which feature is optimally placed with a layer on its own like this, okay. So normally in the deep learning, okay, how many layer we need to apply, okay, normally it start with the breeding layer by layer method, okay, it's trying to put many layer as much as possible, okay, and deep learning eliminate the feature engineering. It just means you don't need to do the pre-processing anymore, okay. Like you have to delete spite or something like that, but you don't need to extract the feature or extract the important information. You just feed the raw data, and then the deep learning method will extract itself, and then use that information for the next layer like this. Okay, so that's why it doesn't need any feature engineering anymore. Okay, one of the architecture in the deep learning is the famous one, deep neural networks. Okay, deep neural network is mean you have many layers in the artificial neural network. Okay, this is just an artificial neural network, just ANN, okay, but with the many layers between the input and output. As I mentioned that, okay, maybe 10 or 100, something like that, many layers, okay, and can model complex nonlinear relationships, okay, and when no layers are recursive neural network, okay, normally it's applied for the natural language processing, okay, or speech recognition, something like that, okay, and also it can be applied for the time series predictions, okay. Another RNS, there are various versions of the RNS. Okay, I will discuss in the next week. Okay, second, when no deep neural network is a CNN. It's used in the many image processing or image recognition. That's a CNN. C is mean the convolutional deep neural network. Okay, and challenge in the deep neural network, the data, okay, because your model is very complex, okay. To train that model, okay, you need a very large data, okay, like big data, okay. But currently, you can get the many data, okay, large data. So that's why it's enhance the deep neural network design, okay, and the hardware, okay, you need very high speed GPU or something like that, and that is take time to train your model, okay, and sometimes it can overfitting happen, but it can be controlled by regularizations, okay. So let's start one of the neural network, that is a convolutional neural network, okay. But actually that one, okay, this is at first, okay, this one is like the feature expression. It's use a convolutional method, image convolution, two-dimensional convolution, okay. And then after that, it's used like the neural network, okay, that we call is a fully connected network, okay. How they do is, for the first part, it just extract the feature, so that we call is a feature expression, okay. And that second layer, okay, that we call is a classification. Okay, it's used by the neural network, multi-layer perceptron neural network with the many layer. Okay, to classify the object or image. Okay, and then finally at the output layer is use a shortcut activation function. Okay, because normally in the convolution, okay, you can classify or you can connect many objects. Okay, so that's why we have to use a shortcut because we have many categories. So what is a convolutional neural network? Based on the share weight architecture of the convolutional kernel or the filter. Okay, as name mentioned that at the beginning, it need to do the 2D convolution a lot. Okay, 2D convolution is mean you have your input two-dimensional data, and then we have another small. So this one appear as a metric. Okay, and then we have another small two-dimensional metric. Okay, and then we convolute between that two. Okay, this small one we call as a kernel. Okay, it will be the same as the kernel functions in the 1D calculations. Okay, or sometimes we call as a 2D filter. Okay, and then in the convolution, it means we slide that small filter along the inputs and then calculate the summation of steps. Okay, multiplication of this filter. This one is actually is composed by weight W multiplied with this each input element or puzzle. Okay, and then calculate the convolution like this. Okay, normally it's applied in the many applications, image and video recognition or image classification, image segmentation, natural language processing, and also it can use for the time series prediction, especially if you have to consider many input. Okay, not only one. Okay, you have many input, you can apply the convolutional neural network. Okay, so normally for the convolutional neural network, okay, the first part, okay, or we call it the lower layer, okay, or the beginning, we use the two type of the layer. Okay, the first one is a convolutional layer. Okay, and that is also use activation function. After we finish the convolution, we pass to the activation function. Okay, in that case, mostly we use a root. Okay, rectified linear unit. And then another layer is always cascaded. Okay, mostly after the each convolution layer. Okay, that we call as a pooling layer. Okay, this one. And then we normally for this two, okay, sometimes we use a two convolution layer, and then after that we use a that pooling layer, or maybe after that, some cases we use one convolution, one pooling like this, and then we cascade many of things. At the ends, we use that fully connected layer. Okay, fully connected layer is mean like just a conventional neural network. Okay, but the deep neural network, we have to use many hidden layer. Okay, MLP, multi-layer perceptron like this. Okay, so normally for the convolutional neural network can be built or model with those three main types of the layer. And each layer will be increased complexity by identifying greater portion of the image. Okay, it's not this one. And then each layer will focus on symbol feature. Okay, so normally for the convolutional neural network, especially that convolutional layer, okay, we have to do the 2D convolutions. Okay, this is like the image processing. Okay, that's why for that this convolutional layer is need a lot of processing power. Okay, and also the input need to be there two-dimensional. Okay, and then after each layer in the convolutional layer, okay, we have to use that feature detector. Okay, like similar to the edge detector. Okay, and then we have to use many of this one. Okay, and they are called as a kernel or filter. Okay, so normally the convolutional process, okay, it just means this is our input, okay, and then this is our filter or kernel. We have to shift, move this one slowly, okay, not one by one. It depends on the strides. Okay, it's one is mean we move one by one. It's two is mean we move two by two like this until it's cover the whole image. Okay, so like this. So in the convolutional layer, okay, we call as a partially connected. Okay, because each of the outputs. Okay, so you can look at this one. So this is our input. Okay, input image. And this is the filter, okay, and this is output array. And each of the output array elements in the output array, they are not connected all the input, okay. Only it's depend on this filter. If you use 3 by 3, okay, only that 3 by 3 part of the input will be connected to this input. So this output. This one also, okay. If I use a different color, okay, for this one, okay, based on this one, this will use only S3. Okay, so that's why for the 2D convolutional layer, we also call as a partial connected. Okay, and normally, okay, if we calculate like similar to the normal neural network, it also have the forward propagation and backward propagation. Forward propagation is meant to calculate for the prediction. Also need to calculate in the training. Backward is during the training only. Okay, and when we calculate the forward propagations, okay, all the weight are fit. Okay, the constants. So that's why if we calculate the each outputs, okay, have to rely on the one weight. Okay, and then similar to the normal neural network, okay, this value in the fetter, sorry, in the fiddle or the kernel, okay, are called as a weight. Okay, but there are a lot of weight, okay, and those weight need to be updated or adjusted during the training or backward or back propagations. Okay, that is similar to the neural network or deep neural network, dominant neural network. Okay, and then in this 2D convolution, okay, it's controlled by 3 hyperparameters. Okay, and that will be affected the value of the output. Okay, the first one is the number of filter. Okay, normally if you consider that's a gray image, okay, you have only one input layer. If you consider RGB, okay, you will have the 3 layer. Okay, and then each layer you can use 3 filter. And also you can consider 2 filter for each layer, okay, to extract different thing like this. Okay, so anyway, it will be that output will be it's depend on the number of filter and the stride. Stride is mean for each die. How many row or column? Sorry, row or column this input calculation of this filter need to move. If move just one by one, so the stride is one. Okay, if move two by 2, 2, it just means 2. Okay. And another one is whether there is 0 padding or not. It just means some cases, okay, if our input is 6 by 6, and then we want to have the 6 by 6 output, same as input, you have to put the 0 padding. Okay, it just means you have to fill out with the 0 in the empty space at the output. Okay, so based on that parameter, okay, your output will be changed. Okay, and this one show you the different type of the filter. Okay, you can use for the different feature or different application. Okay, but as I mentioned that overall this one will be calculated by backward propagation this way. Okay, the first one is the identification. Okay, so the input will be the same as the output. Okay, and this one is used for the edge detection. Okay, like this, and sharpen, and then so on. Okay, and another layer used in the convolutional neural network is a pooling. Okay, actually the calculation is the same as in the convolutions. Okay, we have the bit input, we consider small window, and we move around that small window, and then based on the value covered by that small window, we calculate the output. Okay, but in this case, we don't do real convolutions. Okay, what we do is, okay, without wait, what we do is from that window, okay, if we find just a maximum or the highest value, okay, that we call as a mask pooling. Or if we just calculate, okay, like 2 by 2, okay, so we read 4 element in here, adjacent 4 element in the input, and then we find the average. Okay, that is mean average pooling. Maximum is mean from that 4 we find the maximum one. Okay, we just calculate that thing. Okay, the intention of the pooling is to reduce the size of input. Okay, if we run with the 2 by 2, okay, let's say this is 6 into 6, you will have the 4 into 4 like this. Okay, it's reduce the size of your input. Okay, and it may lose information. Okay, but it can reduce the complexity, and also it's improve the efficiency and mitigate the risk of the overfitting. Okay, like this. And then finally, you have to pass through the fully connected, okay, neural network. Okay, that one will be do the classification job. Okay, based on the feature is extracted during the lower layer in the convolutional layer. Okay, and then it will be classified as the ends. Okay, like this. Today, let me stop in here. Okay, and then next week, I will show you some numerical example of the convolutions, and then after that, I will discuss about the recurrent neural network. Okay, I will give you some example, and then finally, I will discuss about the generative adversary neural network. Okay, network. That is okay. So tomorrow I will upload the assignments. Okay, so please try to solve the assignments. Okay, it will be very similar to the example I just showed you today. Okay, so good night.
Thank you.
Thank you. ขอบคุณครับ